Hello everyone. In this session, we are going to talk about diagnosing a JVM crash, how a Java developer can troubleshoot JVM crash, how we can analyze a Codom file. My name is Vipin Sharma. I'm a senior software developer. I have 13 years of experience. I help professional Java developers to learn language features so they can work on the best Java projects. I write about language features on jfeatures.com. This is a typical HS error file. When you have a JVM crash, you get HS error file and you get a core dump. When you open HS error file, this is what you see on top of your screen. A fatal error has been detected by Java runtime environment. Then it tells me it was created by a kill command, kill minus 11. I created this. And then it talks about JVM version, Java VM. Then it talks about core dump. What is the core dump location? And then at the end it says if you would like to submit a bug, please visit this. Okay. So typically, if we have a JVM crash, what we do is we go to this URL, we submit our bug, right? It depends on your vendor. Maybe you have a different JVM vendor, you get different URL, and you submit your crash report over there. In this talk, I'm going to explain how a Java developer can troubleshoot JVM crash. JVM crash creates a code dump file. How a Java developer can read that code dump information. For that, OpenJDK provides a command line tool, JHSDB, a very helpful tool to analyze these problems. We will see how JHSDB works. We'll take a demo. We'll connect it with a code dump. We'll connect it with a live Java process, and we'll try to see how it works. Let's try to see why do we have JVM crash problems. So the common causes are typical bugs in five categories I have listed over here. First is Java Hotspot VM, second is system library, and then Java SE library or an API, in application native code, or in operating system. And out of these applications as well, the majority of bugs falls under two categories. First is running out of native memory, where native memory is exhausted, you don't have more memory to allocate. And second one is segmentation fault. This is caused when a program is trying to read illegal memory location. That means it is trying to read or write to a memory location which it does not have access to. For later part of the talk, we will need a Codom file to do more analysis. So first, let's try to run a Java program and we will generate a Codom. In practice, you may not need to do this because when you get the JVM crash, it is going to generate Codom for you. So this is a Java program I started. Okay, let's see what is my process ID. So my process ID is 74281. Okay, now I will do one thing. I'll start a GDB session. I'm going to attach my process here. Okay, now I'm going to run a command gcore and I'll name it JVM dump. It is going to generate the dump. Okay, it is generated. It says saved file. Now I'll detach and I'll quit GDB. Let's try to see if file is generated. Yes, we have the file. Okay, so this is just a simple command which does nothing. It runs a while loop, infinite loop, and we have generated a Codom file. When you are using GDB, and if you want to take a look at thread stack trace, then it will show you stack trace of native process that will include operating system calls, C++, classes and methods. But that is not a friendly experience for Java developers. Java developers needs Java classes, information related to Java classes. So which method is called, which class is being used, how much memory is used, what is your heap size, and what were the parameters passed to this JVM. So this kind of information a Java developer is looking for to analyze a JVM crash. Let's try to analyze the codem file we created using GDB. So this GDB command, I'm passing two arguments. First one is Java executable and the second one is codem file. Okay, now I'm going to try command BT, which is going to give me backtrace. This is going to give me stack trace. Now, if you look at the output of this command, it talks about .c classes, main.c, java.c, and then we have pthread join common.c. So, for a Java developer, these are not friendly names. We cannot figure out, oh, what is this doing? What is this application doing right now? So, Java developers need Java files, Java methods, Java classes. GDB is tool for C++ developers. Okay, so let's try to see JHSDB, which is the command useful for Java Codom. JHSDB is part of OpenJDK, which is base for all the commercial JDK versions. Now JHSDB has couple of modes. First one is command line debugger, which is CLHSDB. Then second one is HSDB, which is a UI debugger. Then third is debugd. It can start a debug server and we can attach our process to it. We'll see this with an example. And then it has JStack, JMap, JInfo, and JSnap. So we'll see all these available modes as well, how it can help. JStack, JMap, JInfo, and JSnap are common tools Java developers are familiar with. JHSDB help us to use these tools on a Codom file. We'll see these examples in a while. Let's start our analysis with command line debugger CLHSDB. So this is the command I'm going to run. If you look at this, it is saying JHSDB run this in command line debugger mode, and with core I'm supplying the core file, Codom file, and with the exe I'm specifying the Java process which created this core file. Okay, I'll run this. Now it has opened core file, it has attached core file, and we can start troubleshooting Codom. So the first thing we would like to see is help. Help gives you a couple of commands you can run. The commands available here. Okay, so you see these are list of commands. Okay, let's try to see a couple of common problems we may want to debug. So the first one is we may want to see thread information. So first I'll see threads. It will give me all thread IDs. Okay, so now I got all these thread IDs. Let me try to pick my thread. And before that, I can show you the Java program which generated this code. This is my Java program, very simple program. It has public static void main method. Inside main method, I'm doing certain things. And at the end, I'm saying, okay, yes, run a while loop forever and just start creating this new object. Okay, So let me go back to my JHSDB. Let me try to see where is my thread. Okay, here we go. This is my main thread. This is my thread ID 74320. Okay, now I'll try to see more details on this thread. So using where command, we can see more details, complete stack trace. But in this case, it's just one method, so you don't really have a stack really. But yes, this is the useful command if you want to see stack trace. Okay, and a couple of times, you want to see Java heap related information, memory related information. So using universe, you can see heap related information. So it is using G1 heap and regions, capacity, used, free, then G1 young generation you see here, hidden space, survivor space, old generation, all this information related to G1 heap. You can also see a histogram. You can get histogram using jhisto command. This is the way you get histogram. Okay, let me try to show you on top of it. So here's your histogram. It says first one is the index and then number of instances, then the bytes used by the particular class, and then it has class description. So at times it is helpful when you see some object which is created a lot of times and that is not expected. So you can clearly figure out the problem there. Like in this case, I can see, oh, I'm creating an object, number of objects. So like 1142. This is a very simple program. Why would I create number of 1100 objects? Because we are creating it in a while loop. This is a problem, right? Okay. So this is very helpful command jhisto. Now, sometimes we want to see system properties passed to this Java program. You can see system properties by sysprops. These are the system properties. For example, Java specification version, and this is my username, VM vendor, this is my OS version. Okay. Now the last thing I would like to show is JStack. Using JStack, which is our favorite command to get a thread dump, you get a nice thread dump. This is the same information you get using JStack command. Very similar output you see here. Okay, it says no deadlock found, and then it prints all the status. Okay, I'll quit this mode. So what we have seen is we tried to analyze a codem in command line mode using JHSDB. Now we can see the same thing in UI mode as well. In UI mode, we need to use parameter HSDB rather than CLHSDB. Okay, and this is going to open a UI. Let me start this. I'll show the UI in a moment. This is the UI mode. Now in this window you see we have list of threads. All these are list of threads. We see 74320 is our thread ID. Then we have a couple of other options. We can go to tools. In tools we can click on deadlock detection. Okay, no deadlock. Okay, then couple of other things like we can see access flags. All the access flags. You can try to see if it is using G1 heap or not. So Let's try to verify. Use even GC should be true somewhere. Yes, use even GC is true here. Okay, a lot of options available, a lot of command line flags available. Then we can see VM version in this way. I'm running JDK 18. Then we also have option to check histogram. This is where we can check histogram. Okay, same view we had seen earlier. Let's look at the third mode, debug D. So this is command to run debug D. Now, what is different here? One thing is instead of HSDB, now I'm using debug D, and at the end, I'm specifying a server ID so that I can connect with this debug server. Okay. So when I run this, let's do this. This is how I'm running debug D. It says debugger attached and RMI services started. Okay. Now I can connect with this. Okay. So this is the command to connect with this. JHSDB JStack hyphen connect test at the rate local. So test is the same we have specified here, server ID test. Okay. And what we are saying in this command is run JHSDB in JStack mode, but connect with debugd debugd server, which is test at the rate localhost. Okay, so we are trying to run a JStack command over the core dump. The core dump, which is loaded by our debugd. Okay, so let's do this. Okay, yes, here we have the thread dump using JStack. Okay, and this is our command. Okay, let's try to look at different modes and we'll see what we did just now. So we have seen command line debugger, then we have seen UI debugger, and then we have just now seen debug in JStack. So what we did was first we started a debug server using debugd. This is how we did it. This is the command. Okay, at the end we specify server ID test, and we used JStack option to connect with the debug server we started using this command. With this, I would like to explain. First, we connected JHSDB using hyphen core option, and then we connected JHSDB using connect option. There is third way also available. We can connect JHSDB with a Java process, with a running Java process, and that is a PID option. We can quickly take a look at that. For that, we'll try to run a Java program. This is my Java program. Okay, now I need ID, process ID. This is my process ID. Okay, this is my Java process ID. Now I'll use third way to connect JHSDB with Java process. JHSDB, and then I would say use command line mode, but connect with a process ID rather than using a code dump this time. Oh, you need to be careful with this command because you should use this command only when your process is stuck, process is hanged, and you know you're going to be restarting this application. Otherwise, there are chances after using this command, your process may get hanged. So be careful with that, and let's try to run this. Okay, so it has attached with our process. Let's try to see threads. Yes, we have threads. Let's try to see JStack. With JStack, we can see the information here. Let's try to see our Java class. Yes, this is my main thread, and I'm running test.main. Yes, only main function I have in my sample class. Okay, so it was the third way to connect with Java process using JHSDB. So far, we have seen a lot of examples of JHSDB. Now, we should try to recap what we saw so that it doesn't become confusing for you. So the first thing is JHSDB modes. JHSDB has a couple of modes: CLHSDB, HSDB. So we have seen this command line debugger, UI debugger we have seen, and in debug D mode we see how we can start a debug server, and to that debug server we can connect other processes: JHSDB, JStack, JHSDB, JMap. Similarly, okay. Now the other thing we saw so far is connecting with JHSDB. There are three ways. We connected with PID option, and this is the example: JHSDB, JStack, PID 1234. 1234 is just an example of PID. We can also use core option, and using core option, we can attach a Codom file. So if you look at the examples, it says JHSDB, JStack, and I'm using core, and then I'm specifying the Codom file path, and then I'm specifying exe, and this is my exe. Exe means the Java process. And then we have connect option. So when we start debug server using JHSDB debug D, we need to use connect option. And the connect option works like this: JHSDB JStack connect ID at the rate debug server. Now, one thing important is we can use we are using JStack here for all the examples: JHSDB JStack for PID, core, and connect, all the examples. But you can use JMap, JInfo, JSnap as well. Okay, so in this way it becomes a normal JStack, normal JMap command. For more information on JHSDB commands, different modes, different ways to connect, if you want to look at the examples, you should go through these two blog posts I created. One is available on my blog jfeatures.com, other is available right now on javaadvent.com. Now we'll try to see how can you take advantage of help available in OpenJDK for JHSDB and different commands we have seen. And how do you understand what are the different options available? Okay, how do you read more about that? So the first thing is we'll run JHSDB. With JHSDB, the one thing there's good thing about OpenJDK is all the commands work with help. So you just need to say command name and then type hyphen help, and you will see help related to that. So in JHSDB, this is help. We have already seen this. Okay. Now let's try to see more details into the options. I'll say CLHSDB and then I'll say help. Okay. So if you look at this, first thing it gives three options. You can attach a PID, you can operate on a Codom file, and then you can also attach with a debug server, remote debug server using debugd, which is created. Okay, and exe, what is exe? You need to specify exe, executable for the core file. That means in our case for the JVM Java process. Okay, and now this is some documentation about this same thing, and these are examples here. You see JHSDB, CLHSDB along with PID, along with core, along with connect. We have already seen three ways to connect it. Now let's look at another help with HSDB. With HSDB as well, something very similar. You have similar commands, all the similar options. Now we'll see help related to another commands. See what is the next. We have next is debug. Okay, so I'll check debug related help, and here it is. Gives couple of options. What is server ID? What is server name? What is RMI port? Registry port in case you need to set in some case. What is host name? Disabled registry. And then again, these are standard options. You connect it with PID, core, and then what is exe. Okay, and then here we have two examples, PID and core. You don't have a connect option because connect option can be used when you start a debug server using debug, and we are running debug here. Okay, so let's look at the next command. Next command is jstack. Okay, so jstack help. This is going to be a little bit interesting. So first thing is logs. It prints Java util concurrent logs information. And next thing is mixed. With mixed, it prints both Java and native frames. Stacks typically gives a Java thread dump, but if you use mixed and you're using JHSDB, then you have an advantage. You also get native frames. That means C and C++ stack trace as well you get. We'll see that with an example in a while. And after that, these are standard options we have already seen. This is the same documentation, and these are examples. How do you use JHSDB JStack with PID, core, and connect with the a debug server? Okay, now we'll see JMap help. With JMap, there are a couple of options. You can see you can print heap summary, you can print using binary heap, dump Java heap in hprof binary format, and then you can give dump file name. You can specify GG option to compress that and compress that to what level. You can specify that. You can print histogram. Couple of these things we'll see later in our examples as well. And then some of the things are similar like PID, core, exe, connect. We have already seen, and that's like this is text around those commands, those options. Let's come back to our demo. We'll see a couple of more commands. So we have seen so far command line debugger, UI debugger, and debug mode. Let's look at more details on JStack, JMap, JInfo, and JSnap. So for that, first thing is I'll see what are the help options available in JStack. Okay, these are the options available, and we would like to see logs and mixed related information. Okay, so JStack is it's the same JStack command. The difference is we are using JStack along with JHSDB to analyze a Codom file. So this is going to be the command. And there's also one more difference. We'll talk about it when we are using mixed. Okay. But for now, let me start using this. Okay. And after running the command, you get this thread dump. So this is my command here. And now it says no deadlock found. And this is my stack trace for my main method. Okay. Now we'll try to use mixed option. Okay. When I use mixed, you see this, it has native frames. It says main, JLI launch, continue in new thread, call Java main new thread, right? And pthread. block join X, and then so all these are native frames. These are not Java methods, Java classes. Okay, so this is very useful sometimes if you are trying to understand what is happening in your OS course, native frames, then this is useful. Okay. You can also print logged information. So for that option is logs. In our case, we don't have Java util concurrent logs, so we see logged enable synchronizers none. In this thread as well, it is null. Let's go to our main thread. So it's none. Okay. So first, let's try to run a Java program which can give us Java util concurrent logs. This is a program which is going to create dead log and it uses Java util concurrent logs. So first thing is I'll try to find the PID. This is my PID. Okay. Now for our demo, I'm going to use PID to attach this program JStack. And how do I attach PID? Let me take a look at help. Okay. So this is my command here. Okay. And I also need to specify logs. Okay. Now if you look at this program has some logs. Logged enable synchronizers. It gives this information because it has a deadlock. I'm using Java util concurrent logs here. Okay. So first thing is it says this is my command and it says found one Java level deadlock. And what are the threads participating in that? Pool 1 thread 2 and pool 1 thread 1. Okay. Now we can go to pool 1 thread 1 and pool 1 thread 2. This is my pool 1 thread 1. Okay. And after pool 1 thread 1, I see information related to logs as well. Let's look at the next command. Now we'll see JHSDB JMap. So first we'll see help option. How do we use this command? Okay, this is help option. So first thing is no options. It prints something similar to Solaris PMap. Then we have heap option. Then we have binary heap option, dump file option. Then some recently added options like GZ we have. It uh, it is added for compression level. And then we have histogram option. So we can just print only histogram. We don't need to dump entire file. So this is very helpful. And then we have class loader statistics, finalizer info, and rest of the options are to connect with a Codom or PID or debug the server. Okay, now we have these examples here. JHSDB JMap. This is how you connect with PID. This is how you connect with core and debug the server. So let's try to connect with a core dump file. In this talk, we are trying to understand how to analyze a Codom JVM crash. So let's try to take a look at Codom using JHSDB JMap. Okay, and I'll try to use some option. I think the first option should be histogram, and to this histogram, I think I should take this output into some file. Okay, we have the histogram. Let's take a look at this file. Here it is. We have class description, we have number of bytes used and then number of instances for that class. For example, this is object class and we have number of instances 1142. Okay, we know our program executes while loop, and while loop it is creating object, so this is expected. Similarly, in case you have some problem in your application, you suspect that okay, uh, there are a number of objects created for particular class and that is not expected. Those kind of problems we can clearly see in this histogram, and we don't need to really take entire heap dump. Let's check Java heap related information. We'll use the same command. We'll just modify the option rather than histro. This time we will say take heap information. We don't want to take it in a file. Okay, and now we have the heap related information. This is the Java version, and we are using garbage first collection with 13 threads. This is heap configuration. Okay, and then this is heap uses. We have G1 heap, young generation, hidden space, survive space, old generation. Okay, let's take a look at another command. We'll check class loader statistics. This is where we have class loader statistics. Okay, and let's try to check one more command, finalizer info. So it says number of objects pending for finalization 0. Okay, and at the end, in case you want to take a heap dump and you want to analyze that further into some tool like Eclipse Mat, then you can take entire heap dump using this command. Here I have specified binary heap, dump file, and GG options. I'm selecting GG1, which is the recommended and fastest option. It is taking some time. Okay, now we have our heap. Yes, we have our heap dump generated here. Now we'll see next command jinfo. First, I'll try to print help option. How do we use this command? Okay, so these are help options. First thing is we can use flags to print VM flags. Then we can use sysprops to print Java system properties. And with no options, it prints both. And these are regular options we have seen so far to connect with. And this is documentation about these. Okay, and here we have examples. So I'll take the same command. I'll try to modify the same command, JMap Try to modify JMap. I just need to say jinfo, and then I'll give option flags. I want to print flags information from a core dump file, jvm dump.core, and exe I have specified here, which is my Java process. Let's enter this. Okay, and now we have our information here. These are non-default VM flags. Okay. For example, we are using G1GC, so it says yes, plus use G1GC. Okay, now we have seen one more option. We can print sysprops, system properties. Okay, here we have system properties. Okay, so for example, username is Vipin, and it has Java specification version. It has OS name. Okay, couple of more system properties. Sometimes when you are troubleshooting a problem, you just want to see what was the system property, what was the value of VM flag in my JVM. So this is very helpful command. You have your crash dump and you can see what is system property, what is your VM flag in the Codom. Now we will see the last option, JSnap. So in JHSDB, we have already seen these options. Now we have one more option, JSnap. It provides performance counter related information. Let's see how do we use this command. Okay, so we have only one option, all. If we specify, we get some additional performance counters. If we don't specify all, then by default we have only limited performance counters, and these are the ways we can use this command. Very similar way. Okay, so I'll just take the previous command, I'll modify that. This is my gsnap command. Okay, I execute this command without any options. I see a couple of options like java thread.live equals to 6, live peak equals to 6, daemon threads, number of daemon threads is 5, and couple of more things. Okay, I'll specify all option, and we see some additional statistics as well related to performance. Okay, I'll go back to command to show where is the command. Yes, this is the command, and we see a big list of performance counters. We also see the same info we have seen earlier without minus all, like live threads is 6, daemon threads is 5. So far we have seen uses of JHSDB command and how we can attach a core dump to JHSDB to analyze it further. We can use different options in JHSDB to get stack trace, memory related information, process related information. When you have JVM crash problems, you get fatal error log file as well. Typically we call that HS error log file. Okay, so that is created in the same working directory as of your program. If you do not have permission over there, then it gets created in temp directory. Otherwise you can specify the option java xx error file equals to, and at the end you specify %p that appends PID. Okay, and you can read more about error log file on the link given here. It tells you about different sections of error file and how do you read that. In some cases, you do not get Codom file that is not getting created. For that, you need to troubleshoot that problem, and there are typical regions are given on the link, second link. You can go to that link and you can see common regions. Maybe you do not have permission. Maybe or you do not have view limit set. Now this is time for Q&A. You can send me questions over Twitter or on the Slack channel given here. You can send me an email, and while you are thinking about questions, you can get free ebook 5 steps to best Java jobs from my blog jfeatures.com.